In this video, we'd be talking about histograms. What are histograms and how histograms are drawn. So let's start with the basic definition of histograms. And as per the definition, histograms, these are the diagrammatic representation of the statistical data in the group form, not group form, continuous group form. Continuous group form. And how do we represent it? We use rectangles. To represent the frequency distribution we use rectangles to represent frequency distribution and their classes. Okay. Primarily in our syllabus we have two different types of histograms. Two different types of histograms means on one side we would be having the type of histogram where we have constant class width, and the second type of histograms are the ones where we don't have the constant class width, where we have the variable class width. Variable class width. That means now the class width is not constant, it keeps on varying. Now, these are the two different types of histograms. So first we need to know what do we mean by the term class width, and after knowing the term class width, then we'll look at the case of the histogram with constant class width. So we'll refer to an example directly that will help us in understanding the situation well. So here in this example, I have picked up the continuous group data we have picked up. Okay, so what do we mean by the term class width first? So class width, it's basically the gap between the upper limit and the lower limit. For upper limit, I'm using the term UL, and gap between upper limit and lower limit. For lower limit, I'm using LL, lower limit. Okay. Now in this particular class, let's talk about this very first class. Where we have n, which is the number of cases from 0 till 5. So here, this class is starting from 0. So 0 for us is the lower limit, and this class is ending at the value 5. So 5 for us would be the upper limit. So class width is always a gap between the lower limit and the upper limit. So in this case, if you may see, it's 5 minus 0. So 5 minus 0, it's a 5 only. So class width, if you talk about class width, so class width for the first class, it's 5. For the second class, it's again 5. Third class, 15 minus 10, 5. 20 minus 15, another 5. 25 minus 25. So we have the class width constant here. This tells us that the class width is constant. Class width is constant. So whenever we have the class width constant, we always draw the histograms where we have the frequencies representing the heights of the rectangles and classes representing the breadths of the rectangles to be drawn. Yeah, so what I'm saying is you have to draw the rectangles. Okay, so the vertical axis would always be representing the frequency, and the horizontal axis will always be representing the classes. And classes here in this case, the classes what we have is the number of cases. Okay, we have the range of values of number of cases. All right, now we have to scale it and make sure that you scale in a way that all the values fit in your axis drawn. So for me, vertical axis has to be for the frequency, and frequency we can see it's going from 1 till 11. So we'll keep a gap of 2 units, the 2, 4, 6, 8, 10, 12. And the classes they go from 0 till 25. So starting from 0, it's a 5, 10, 15, 20, and a 25. Now for this data, we will be representing the rectangles on this axis. So as I've told you earlier, the rectangles would be having the heights representing the frequencies and the width representing the classes. So for the very first class, it's 0 till 5 having the frequency 4. So 0 till 5 having the frequency 4 means our rectangle would be from 0 till 5 and goes to a height of 4 frequency. Next, we have 5 till 10, and that is having the frequency 9. So 5 till 10 goes up till 9. Since 9 is not there, so it would be the mid of 8 and 10. Third class we have is 10 till 15, which is having a frequency 11. So 10 till 15 frequency 11, that means it would be somewhere here. Okay, fourth class 15 till 20, that's having the frequency 3. 3 has to be in between 2 and 4. Last we have 20 till 25, which is having the frequency 1. So 1 has to be between 0 and 2. So yeah, this is how we draw the histograms when we have the constant class width. In the next example, we'll refer to the data value where we don't have the class width constant. Let me pick an example for you. Oh, by the way, this question has one more part. Part 2. Before moving for the next example, we have to do the part 2 also. Part 2 says if the delivery driver makes at least 15 trips, at least 15. At least 15 trips each day, he receives an additional allowance of $20. How many days did he receive the additional allowance? How many days? Okay, at least 15 trips. At least 15 trips, it means basically it's 15 or more. So 15 or more, if you may look at the data, they are having, the data is represented by classes 0 till 5, 5 till 10, 10 till 15, 15 till 20. So at least 15 means 15 and more. So for us, this class is there because more than 15 means 15, and between 15 and 20 should be there. But then more than 15 also includes the class next to it, which is 20 till 25. So this class also follows the condition of 15 or more because the class between 20 till 25 is also more than 15. So this class also fulfills the required condition, which is of at least 15, that is more than 15. So we would be counting the frequency of this class also. So for the first class, 15 till 20, we have the frequency of 3. And for the second class, we have the frequency of 1. So that means for the second part where we have to find the number of days the rider got the additional allowance. So these are 3 plus 1. So number of days for additional allowance, number of days is equals to, it's simply 3 plus 1, which is equals to 4. So 4 is the answer for the second part. Now we are moving on to the next example where we would be having the frequency distribution, where the frequency distribution is the frequency, the class width is basically not constant. Let me pick an example. Okay. In this example, what we can see is we always look for the class width first. And looking at the class width here, for the first class, the class width is 1 minus 0, which is a 1. Second class, 2 minus 1, it's a 1. 3 minus 2, it's a 1. 5 minus 6, a 2 now. And 8 minus 5, it's a 3. 12 minus 4, it's a 12 minus 8, it's a 4. So we have a varying class width here. So this is the case where we have the variable class width. Okay, variable class width. And when we have the variable class width, the histogram is slightly different from the previous one. Here we draw the histograms, or we draw the rectangles where we have the vertical axis or the heights of the rectangles represented by the frequency density. We have another term here, frequency density. So vertical axis or the heights of the rectangle would be represented by frequency density, and the horizontal axis, which is the classes, would be represented by the classes only, whatever data is there. For frequency density, the formula is frequency upon class width. Basically, frequency density tells us that how dense the frequency is there for each class. So for all the classes, we first calculate the frequency densities. After calculating the frequency densities, then we draw the histograms. So let's make another column here, add on another column here, representing the frequency densities. Frequency density. So frequency density is frequency upon class width. So for the very first class is 7 upon 1, that's a 7. 9 upon 1, that's a 9. 10 upon 1, that's a 10. 8 upon 2, that's a 4. 6 upon 3, it's a 2. 4 upon 4, that's a 1. So we got the frequency density. And for your convenience and example, the question is already given us two different rectangles drawn. So if you may look here, for the very first class, which is from 0 till 1, the frequency density is 7. So this 0 till 1 is 7, the frequency density. 0 till 1, frequency density is 7. For the second class, which is 1 till 2, frequency density is 9, and that is also very much evident from the rectangle already drawn. Now we have to complete this histogram by drawing the rest of the rectangles. The third class is 2 till 3 and the frequency density is 10. So 2 till 3 frequency density 10 means the rectangle would go up till here. Third class, we have done. Fourth class, 3 till 5 is the class having the frequency density 4. So 3 till 5 frequency density 4. Next we have 5 till 8 frequency density 2. 5 till 8 frequency density 2. 8 till 12 frequency density 4. 8 till 12 frequency density 1. So these are all the rectangles representing the histogram. So this is how we draw the histograms for the variable class width.